Last year, AI could write your emails. This year, it can decide which email to send, schedule the meeting, analyze and respond, and also follow up automatically. That shift from answering to acting is happening faster than most of us expected. We have seen some surprising breakthroughs recently. AI agents booking travel end to end, system debugging code on their own, autonomous AI researchers running experiments, multi-agent frameworks where different AI systems collaborate like a team. Just few years ago, this sounded futuristic. Today, it's real. And that's the interesting part. This isn't just about a smarter chatbots, it's about a new class of AI systems that don't wait for instructions at every step. They understand a goal, break it down, plan the action, use tools, make decisions, and even adjust their strategy based on the results. And that's what we call agentic AI. We are moving from prompt-based AI to goal-based AI. From tell me what to do to here's the goal, I'll handle it. And that changes everything. It changes how business operate, it changes automation, it changes productivity, and very soon it will change how we design software systems. In this video, we'll explore what agentic AI really means, how it works internally, the difference between single and multi-agent systems, the PRAL loop, that is the thinking cycle behind the agent behavior. We'll also be discussing some of the common design patterns, how to balance autonomy and control, and finally, how you can build your own first AI agent. By the end of this session, you'll not only understand agentic AI conceptually, you'll understand how to apply it. Before we dive into the technical details, here's something genuinely exciting for everyone serious about building the next generation of AI products. The Applied Agentic AI System Design and Impact Program, in collaboration with Microsoft and Simplilearn, is a 10-week practitioner-level expertise designed for professionals who want to move beyond basic generative AI and start designing, orchestrating, and even leading agentic AI systems. You'll gain hands-on expertise in multi-agent systems, RAG, MCP, planning frameworks, workflow automation, and even agentic UX while working with 25 plus industry tools like LangChain, AutoGen, Crew AI, N8N, LangGraph, Azure, and more. Learning is deeply practical with 40 plus demos, 10 plus guided practices, 7 real-world projects, and even a capstone focused on product strategy delivered through live interactive session, mentoring, and even cohort-based collaboration. The program also offers career supports via job assistance, Microsoft Learn badges, and a joint completion certification from Microsoft and Simplilearn. If you're aiming to build autonomous AI systems, lead AI-driven product strategy, and also stand out in fast-growing marketers, this program isn't just an upgrade, it's your launchpad. Enroll now, step into the future of agentic AI with confidence. The link is given in the description box and in the comment section below. Before we kickstart, here's a small question and answer section for you to answer. What makes an AI system agentic? It gives quick answers, it achieves a goal, or is it uses big data set? Let us know your answers in the comment section below. Also, if these are the type of videos you would like to watch, do subscribe to Simplilearn and hit the like button. Without any further ado, let's get started. So let's start with a basic understanding of what agentic AI is. Agentic AI are goal-driven AI systems that can understand objectives, plan multi-steps actions, and autonomously use tools to achieve outcomes with limited human supervision. Let's understand this step by step. First, goal-driven AI systems. Traditional AI systems are reactive. You put an input and they generate an output. But agentic AI starts with a goal. Instead of simply responding, it asks, what is fine outcome that I need to achieve? This shift from response-based AI to outcome-based AI is what makes it powerful. Second is understand objectives. The system interprets what the user actually wants, not just the surface-level instructions. It identifies the purpose behind the request. For example, if the objective is to increase sales, the agent doesn't just generate a report. It may analyze trends, identify gaps, and suggest strategies. Third is plan multi-step actions. Real-world tasks are rarely one-step processes. They involve sequence, which is gathering information, analyzing it, making decisions, and also executing tasks. Agentic AI creates this structure plan automatically. Next, autonomously use tools. This is very important. The agent is not limited to generating text. They call APIs, query databases, trigger workflows, or interact with external systems. That's where real action happens. Finally, limited human supervision. Humans still define the goal and guardrails, but within those boundaries, the agent works independently. So, overall, agentic AI transforms AI from passive assistance into a new active problem solver that works towards measurable outcomes. Next, we'll move on to the layers of the agentic AI systems. It consists of a perception layer, cognition layer, and also an action layer. Let's explore each layer in detail. The perception layer ingests user inputs, events, and data. This means it gathers all relevant information from the environment. It may receive user instructions, system notifications, data streams, or even API responses. This layer ensures that the agent has situational awareness. Without accurate perception, decisions wouldn't be based on incomplete information. Next layer is cognition layer. This layer plans, reasons, and also decides next action using LLMs and logic. This is where intelligence happens. The system analyzes the input, evaluates different options, predicts outcomes, and also selects best course of action. It combines reasoning capabilities of large language models with logical rules and memory systems. For example, if the goal is to schedule meetings, the cognition layer decides to contact, check availability, and also prioritize based on importance. Then comes the action layer. This layer executes the action via tools, APIs, and workflows. Once a decision is made, the agent performs the tasks. It may send emails, update records, call external services, or even trigger automated processes. So the full process becomes clear. First ingest data, then reason about it, and finally execute actions. This layered architecture makes agentic AI structured, reliable, and also scalable. Now let's compare single agent and multi-agent systems. In a single agent system, the one agent handles end-to-end flow. This means it manages everything, understanding the goal, planning the steps, and also executing actions and monitoring outcomes. Single agent systems are simpler to design and monitor. Since only one agent is involved, coordination is straightforward. This makes them ideal for narrow tasks such as report generation, email automation, or even a simple workflow management. They are the best for narrow tasks where complexity is limited and specialization is not required. On the other hand, multi-agent systems involve specialized agents for subtasks. Each agent has defined role. One might focus on planning, another on data gathering, and another on validation, and the next one on execution. These agents work together using a coordinator or protocols to sync their actions. Communication between agents ensure alignment towards the overall goal. Multi-agent systems are best for complex cross-functional work. For example, in enterprise environments, different departments handle different responsibilities. Similar multiple agents collaborate to solve large problems. So the key difference is that single agents prioritize simplicity while the multi-agent systems prioritize scalability and also specialization. Now let's talk about the PRAL loop. The PRAL loop stands for perceive, reason, act, and learn. This represents the continuous operating cycle of an agentic AI system. First, perceive. The agent reads the latest data and events. It gathers information about the current situation before making decisions. This ensures that actions are based on real-time context. Second is reason. The agent chooses the best next step. It evaluates available options, considers constraints, and logically determines what action should be taken. Third is act. The agent calls a tool or an API to execute the decision. This step turns the planning into measurable action. Without this stage, reasoning wouldn't remain theoretical. Fourth is to learn. The agent updates memory and strategy. It evaluates the outcomes of its actions and refines future behavior. This makes the systems adaptive rather than static. The PRAL loop is continuous. After learning, the agent perceives again, reasons again, acts again, and also learns again. This cycle enables continuous improvement. This loop is what makes agentic AI dynamic and also intelligent rather than just automated. Next, here we have three common agentic design patterns. First is planner executor. This pattern separates long-term planning for low-level actions. One component focuses on strategy and decision making, while another handles execution. This separation increases clarity and reduces errors. Second is tool user. In this pattern, the agent selects and invokes external tools based on the goal. Instead of relying only on internal reasoning, it leverages APIs, databases, search engines, or even computational tools. Choosing the right tool at the right time is critical. Third is reflective agent. This type of agent self-evaluates its own outputs and improves them. After generating a result, it reviews and refines it. This improves reliability and also quality. These patterns provide structure instead of building random automation workflows. Developers can follow proven architecture approaches to design scalable and efficient agent systems. Next, here we will see the relationship between risk of impact and level of autonomy. As we all know, when risk is low, safe automation such as suggestions only can be allowed. For example, content recommendation or draft emails. As autonomy increases, we may allow batch actions with review. This means the agent performs tasks, but humans approve them before final execution. When systems access sensitive environments, limited access is important to reduce risk. For high-stakes agents, strict guardrails and approvals are necessary. These systems require strong monitoring and human oversight. The key takeaway here is to increase autonomy slowly as the guardrails and monitoring mature. We should never jump directly into fully autonomy in high-risk environments. Balancing autonomy and control ensures innovation without compromise in safety and accountability. Now let's talk about your first agent. To build your first agent, follow the checklist. First is to choose one boring or any repetitive workflow. Automation works best when the tasks are predictable and frequent. Second is to define a clear goal and success metric. The agent must know what the success looks like. Measurable objectives ensure accountability. Third is list the tools or APIs the agent must use. Agents are powerful because they interact with systems beyond simple text generation. Fourth is to start in recommendation mode. They add approvals and automation. This reduces risk and builds confidence gradually. Finally, increase autonomy slowly as guardrails and monitoring mature. Scaling responsibly, ensuring long-term success. Following this checklist allows you to experiment safely while building effective agentic AI systems. We are entering a new era of AI, from reactive chatbots to proactive digital agents. Agentic AI is not just about smarter responses, it's about autonomous systems that can think, act, and improve. But with great autonomy comes great responsibilities. The future belongs to those who can design intelligent systems with structure, guardrails, and also purpose. Whether you're a developer, researcher, or a business leader, understanding agentic AI today is one of the major skills that needs for your job. It will prepare you for the AI-driven world. Let us know your thoughts on agentic AI in the comment section below, and also don't forget to like and share this video. Hit that subscribe button for more such content. Thank you and keep learning with Simplilearn.